Okay, in this lesson, we are talking about solving equations still, but we're going to talk about some special cases. And hopefully you'll see what I mean when I say special cases. Up until now, every time we solved an equation, we got a single answer of some sort. But today that's going to look a little bit different. So the first thing we want to do is we have some balance scales here. So we can notice that all three of these balance scales are supposedly in balance. But what we have to do is determine if they really are or not. So we're going to determine that if this is always true, sometimes true, or never true. Okay, so if we look at the first one, we'll notice that we have three x's and a 4 on the left-hand side. So I'm going to write that as 3x plus 4. And then on the right-hand side, we have three x's and we have a 10. So I'm going to write it as 3x plus 10. Okay, so then the question that we have to always ask ourselves, is this true? Is it always true? Is it sometimes true? Or is it never true? And the key to this question is the 3x. The thing we should notice is we have a 3x on both sides. So no matter what value of x I plug in, the 3x on each side is always going to be the same. But then on the left-hand side, we're adding 4, and the right-hand side, we're adding 10. So if we add 4 to a 3x, or we add 10 to a 3x, that means that those two things can never be the same. So the answer to this one is never. They are never the same, because 3x plus 4 is never going to be equal to 3x plus 10. Okay, let's look at another one. So in the middle, what we can do is look at this one and say, hey, what do I notice about the left and right-hand side? Well, I notice there's a 4. I notice there's three x's. I notice they're exactly the same, except they're just reversed, right? So they're reversed from one side to the next. So we have very similar. So we have 3x plus 4 equals 3x plus 4. Okay, and same thing, I'm going to look at that x first. If they are the same, that means that whatever I plug in for x, 3x is going to be equal to 3x. But then on each side, I'm just adding 4. So that means no matter what I plug in for x, these two things are always going to be equal to each other. So I'm going to say this is always true. Okay, let's look at one more. All right, this one looks very similar to the last one, except on that left-hand side, we only have two x's instead of three x's, right? So let's go ahead and write what we know. So we have 2x plus 4, and we have 3x plus 4. Okay, so the key to this one now, instead of looking at the 2x, they're different. So we know that if I plug in a value of x, 2x is not going to be equal to 3x, right? That's true except for one time. There's one time when it is going to be equal. So the thing I'm going to look at, though, is I'm going to look at the plus 4. So this plus 4 tells me something. If I can make 2x disappear, and if I can make 3x disappear, then I know this is going to be equal. And there's one way we can do that, and that's if we plug in a 0. So if we plug in a 0 for 2x and a 0 for 3x, those two things disappear, so we end up with 4 equals 4. So that is true. But then what if we plug in a 1? If we plug in a 1, we end up with 2 plus 4 equals 3 plus 4. Well, that's not true. So because of this, we need to say this is sometimes true. Okay, so these are three examples of situations that we're going to run into, and we're going to talk about them a little bit further. So let's look at these three examples down here below. So the thing I'm going to look at first is 5x plus 12 equals 9x plus 12. So this looks very similar to that last one we just did, because we have a plus 12 and a plus 12. And there are some numbers that are going to make this not true, and there's one number that's going to make it true. Okay, so one thing we can do is, if you can't see it, we're going to just solve it, right? So let's just solve it. So we're going to do this. We're going to subtract 5x from both sides. Whoops, I can't do it with the highlighter. I need to do it with them. Oh, I did it again. Here we go. 10. There we go. Whoops, nope. All right, so I'm going to subtract 5x. So I end up with 12 equals 4x plus 12. So this is really similar. We should start to look at this and say, hey, I see 12 is equal to 4x plus 12. I can't add anything to 12 to make it equal to 12, so somehow I have to make that 4x equal to 0. Well, you're going to see how we can do that. So we're going to subtract 12. So we end up with 0 equals 4x. And then we're going to divide by 4. So x is equal to 0. Okay, so this is one of the special cases that we have where it's sometimes true, and the times that it is true are when x equals 0. Okay. All right, so the next two, what we're going to talk about here is an equation that if it has no solution, we would say it's never true. And if it has infinite solution, it's always true. Okay, so infinite means many, right? So it's going to have many solutions, and no solutions means none, right? Now, the one thing I want you to be careful with is don't get 0 confused with no solutions. It's really easy to do. Some people see 0 and they think, oh, 0 means nothing, so that means no solution. Well, not quite, because 0 is a solution. No solutions means that there is no number that will work as an answer. All right, so let's look at this middle one here. So the thing we want to look at right away and notice is, hey, we've got a 3x and a 3x. And from what we were talking about earlier, if we have 3x and 3x, we can't subtract different things from it and expect to get an answer of some sort. But let's go ahead and go through the process of solving this, and you'll see what's going to happen. So I'm going to start with my x's here. I'm going to subtract 3x. And I end up with, oh, that cancels, and that cancels, so I end up with negative 9 equals negative 15. And this is going to seem really weird to have an equation like this that doesn't have an x in it, but it's okay for this to happen. And when this does happen, when we have one thing that does not equal the other thing, we have to just say that it has no solution. So there's no number we can plug in there because there's no x left, right? So we're going to say this has no solution because negative 9 is not equal to negative 15. Okay, so that's a case where it's never true. All right, so let's look at this other one. And the first thing I want you to notice is that the right-hand side is exactly the same as the left-hand side. I said that backwards, didn't I? This is left, that's right. Okay, my son has to hold his fingers up in the shape of an L. Maybe I should do that too. But if they're exactly the same on one side or the other, we're going to see something happen here when we solve this. When we solve, we're going to subtract 8x. Okay, so when we subtract, they cancel, so we have 1 is equal to 1. Now, if we look back at the middle one, why can't I look back at the middle one? Here we go. We had two things that weren't equal to each other in negative 9 and negative 15. But in this case, we have two things that are equal to each other. 1 is equal to 1. So we know that this is always true, right? 1 is always equal to 1. So if that's the case, then we have to say that it has infinite solutions. Okay, so there we go. So these three examples illustrate all of the special cases that we are going to run into. We'll run into cases where we have 0 as an answer. We'll run into cases that are never true, like -9 is not equal to -15, so that means no solution. And then we'll run into cases that are always true, where we have something like 1 is equal to 1, so that means it has infinite solutions, or we can plug in any number for x and it'll make that equation true. Okay, so now that we've gone through that, there are 3 that I want you to try on your own here. And these 3, they're in red boxes, so you're going to end up submitting your answers to an assignment on Schoology. And when you have submitted them, come on back and we'll take a look at some more examples. All right, so 2 more examples. Sometimes you're going to have to simplify before you can recognize whether or not it's going to be infinite, none, or x equals 0. Because if you look at this first problem on the left, well, we can't tell if the left side is equal to the right side, or if the x's are going to be equal to the x's and the numbers are going to be different, or if we might have a case where the only thing that we can plug in is 0, okay? So the first thing we have to do is actually just do some simplifying. So we're going to distribute that too. So I have 4x plus 2x minus 22 equals 6x minus 22. Okay, so right away we can see, hey, I've got a 22. I've got a minus 22 on both sides, so that's heading in a direction that maybe I'm going to have something similar. But then the key thing here is to notice I've got like terms that I can combine. So 4 plus 2 is 6, so I have 6x minus 22 equals 6x minus 22. And anytime the 2 things on the left and the right are identical, we know that we are going to have infinite solutions. So we can immediately, we don't even have to do any more solving. If they look exactly the same, we can say, hey, this is infinite solutions, which means any number that I plug in for x is going to make this equation true. Okay, let's look at one more. So now in this case, again, we can look at it and see, hey, well, I've got a -3x plus 29 on the left-hand side, but I really have no idea what's on the right-hand side. So I need to do a little simplifying before I try to determine whether or not this has no solution, infinite solutions, or x equals 0. So I'm going to distribute that -11 to both of those. So I'm just going to write down my left-hand side here. And then when I distribute, so this one's a little bit more challenging distribution because we're distributing a -11, so it becomes -11x. And then -11 times -3 is +33. Okay, but then I'm still not completely simplified because I've got a -4, +33, and I need to combine like terms. So I have -3x plus 29 equals -11x plus 29. Okay, so if we think about the examples that we went through, we can look at this and say, I've got a +29 and a +29, but I've got different x's, right? I've got a -3x and -11x. And the thing I need to remember is, if I plug in a 0 for x, it'll make this equation true. But if I were to plug in a 1 for x, it would make this equation not true. So that means that the only answer that we can give is x equals 0. Okay, so you have 2 more to do here on your own. When you are finished with those, go back to that same assignment on Schoology, submit these 2 answers on there, and we will take a look at it for you.